Hello students, the topic is Prim's algorithm. While discussing the minimum cost spanning tree, we discussed that how can we get the minimum cost spanning tree. The first method was that we can draw all the possible spanning trees and then we find the minimum cost spanning tree out of them. So this was the one method. The second method was, which is the greedy method, that is comprising of two methods. The first is Prim's algorithm and the second is Kruskal's algorithm. So let us discuss first the Prim's algorithm. So in the Prim's algorithm, we will be given a weighted spanning tree, a weighted graph. You can see, but in order to find the minimum cost spanning tree, there must be a cycle and there must be one graph. If there are more than one graphs, then we will not be able to calculate the minimum cost spanning trees because the cost of the minimum cost spanning tree will be just one. It will be single. We cannot have more than one cost, the minimum cost. So what the Prim says that you have to take the minimum cost edges first. See, we have taken the minimum cost edge out of the given problem. So the minimum cost edge was 1 to 6, that, and the cost is 10, right? And the next minimum cost edge is 3 to 4, 12. But we cannot take that one. Why? Prim says that if a further minimum cost edge is taken, then we would not be able to maintain the tree. So Prim is trying to maintain the tree and he says that the next minimum cost edge must be connected to the already selected vertices, right? So the already selected vertices are 1 and 6. So the edges connected to 1 and 6 are 25 and 28. So 25 is smaller out of both of them. So we will take 25. Right? We have taken the 25, that is 6 to 5 edge. The next connected edge and the minimum cost edge is we will take out of 22, 24 and 28. So the minimum one is 22, that is 5 to 4. So we will take that. And the next minimum will be out of the possible edges are right now connected to the already selected vertices, that are 1, 6, 5, 4. The connected edges are 24, 18, 12 and 28. So we will take the minimum out of them. So the minimum out all of them is 12, right? So we will take the 12, that is vertex 4 to 3. So we will again take a look at the problem and we will take the minimum one connected to the already selected vertices. So that was 16. We have taken the 16, that is vertex 3 to 2. So then we will again take a look and we will take the minimum one, that is 2 to 7, and the cost is 14. So here you can see that we haven't taken, let's discuss this edge first. We haven't taken the 1 to 2, that is 28, right? Why we haven't taken this edge? So if we connect 1 with 2, this will create a cycle. But in a spanning tree, we cannot have a cycle. We can only have a cycle in the graph. Whether it is weighted or unweighted, it does not matter. But in a spanning tree, we cannot have a cycle, right? Now let's take a look at this edge 5 to 7. If we connect the 5 vertex with 7, this will also create a cycle. Now if we are having another edge that we haven't drawn in our spanning tree, we haven't connected those vertices, that is 7 to 4. If we connect the vertex 7 with 4, this will also create a cycle, and in spanning tree we cannot have a cycle. So this is the minimum cost spanning tree which we have drawn using the Prim's approach, which is a greedy method. So now if we calculate the cost of this spanning tree, this is the Prim spanning tree and this is the minimum cost spanning tree. So the cost of this tree will be 99. So this is how we have used the Prim's algorithm, which is the first method, the first greedy method to find out the minimum cost spanning tree. Now let us discuss the Kruskal's algorithm using the same graph. See, we are having the same graph. So Kruskal algorithm, Kruskal says that you have to select the minimum edge first. So we will take a look at the problem and at the graph, and we will take the minimum cost edge first. So the minimum one out of it was 1 to 6. This is the initial one. So we have selected it. Kruskal says that you have to select next the minimum cost edges. It is quite different from the prims. So we will select the minimum one after 10 is 3 to 4. So we will select that edges also, right? So we have selected another minimum edge 3 to 4. Now we will select the next minimum edge, that is 2 to 7. The cost is 14. We will select that edge also. See, we have selected the 2 to 4, 7, cost is 14, and the next minimum one is 2 to 3, the cost is 16. And now the next minimum after 16 we are having is 18, but if we connect 7 with 4, it will create a cycle over here, so we will not take the edge 7 to 4. The next minimum one is 5 to 4 and the cost is 22. So we can connect them 5 to 4, 22. It's not creating any of the cycle. So after 22 we are having 24. So if we connect 5 with 7, it will create a cycle over there. So in the spanning tree we cannot have a cycle, so we will not connect them. The next minimum is 25, that is 5 to 6. So we can connect 5 to 6. Yes, we can connect them. It's not creating any of the cycle. And the last one is 28, 1 to 2. So if we connect 1 with 2, it will create a cycle in the spanning tree. So we cannot connect them. So this is how you can use the Kruskal algorithm to find the Kruskal spanning tree and the minimum cost spanning tree. This is a greedy method, Kruskal's algorithm, to find the minimum cost spanning tree. So these were the greedy methods which we can use to find the minimum cost spanning tree, Prim's algorithm and Kruskal's algorithm. So what is the difference between both? Between the Prim's algorithm and between the Kruskal's algorithm? Prim says that you have to take the minimum cost edge first, but the next minimum edge will be those which are connected to the already selected vertices. If you take a minimum cost edge far away, then it is not sure that we will get a tree. Kruskal algorithm says that you have to take the minimum cost edge first and then you have to take the minimum cost edges, but make sure any of the edges does not generate a cycle. So this is how Prim's and Kruskal's algorithm are different from each other. Now if we calculate the cost of this algorithm of the Kruskal's spanning tree, so we will get 99. How we calculated this cost? We just sum up all the cost of the edges, so we got this cost. Same, if you remember, in the Prim's spanning tree we were getting the same cost, 99. So these are the greedy methods. You can use any one of them, right? And here you can see that both the costs are same. We have also shown you the difference. So If we discuss the complexity of both, so here we were having edges, and how we can calculate them, the spanning tree edges, we will just minus 1 from all the vertices, and we will have the edges of the spanning tree. So how can we calculate the complexity of minimum cost spanning tree? So see, we are having the vertices here and the edges in the minimum cost spanning tree, or the Prim's or Kruskal spanning tree. So the complexity will be V into E, right? So now we can modify them. The big O of n into E, n here is the number of the vertices and E here is the number of edges. So we can have n number of vertices and we can have n number of edges. So we can say that the complexity of minimum cost spanning tree is n square, right? So this is how we can also calculate the complexity of the minimum cost spanning tree.